In this video, I am going to introduce a new branch of chemistry, a new chapter of chemistry, that is chemical bond. But before to start this chapter, first I want to explain what is stability. Stability means having an electron element of inert gas. This is very important points that you should know, that molecules exist in two different forms. First is molecule of an element, and second is molecule of a compound. Number of atoms present, very important point, this is very important. Number of atoms in a molecule of an element is called atomicity. Atomicity. So, some elements are monoatomic, some elements are diatomic, triatomic and polyatomic. So there is a question that why are some elements monoatomic? Monoatomic means having atomicity 1, and in this category we put inert gas elements, or you can say elements of group 18. So if you say then in monoatomic there is no combination of an atom. Atom exists independently. They are free in the nature. But in diatomic, example is hydrogen, nitrogen, oxygen, two similar atoms combines to form molecule. In triatomic, three similar atoms, O3, ozone. Three oxygen atoms combines to produce ozone. Whereas in polyatomic, we have two types of polyatomic. One is the P4 and second is the SH. So here 4 atoms of phosphorus combines to produce one molecule of element, and here S atom of sulfur combines to produce molecule of an element. So actually what is happening here? If we see the entire part in details, then we find that in case of monoatomic, there is no bonding because they are stable. They have stability. These elements are stable. That means these elements have either 2 electrons or 8 electrons in their outermost orbit. So, chemical bond is a branch of chemistry in which we are going to study how an element attains stability, how an element attains its noble gas configuration, its inert gas configuration, having either duplet or octet configuration. So, what is bond? You can say bond is a type of force. Chemical bond is a type of force which joins 2 or more than 2 atoms to form either molecule of an element or molecule of a compound. So there are 3 methods through which this stability can be fulfilled. First is by transfer of electron. When the transfer of electron takes place between 2 atoms, then in this way stability of the given compound or the bonded atom can be fulfilled. Second, by sharing of electron. Here, sharing of either one pair, two pair or three pair of electron takes place between two similar atoms or between two different atoms. And third type is also just a part of second type. In third type also sharing of electron takes place between two atoms, but shared electron pairs are given belongs to a single atom. It does not here sharing does not involve equal contribution between two atoms. In the second case, sharing of electron takes place between two atoms. Here, equal contribution takes place between two atoms. Here, one atom is involved in the bonding, not is other. So, the first category is known as electrovalent bond, or it is also called ionic bond. Whereas, the second category, where sharing of electron takes place between bonded atoms, is known as covalent bond. And the third category, where sharing of electron takes place, but shared electron belongs to one atom, is a coordinate bond. So one by one I will explain the types of bonding in case of electrovalent compound or ionic compound, in case of covalent compound, and in case of coordinate compound. So the first is the electrovalent compound. The first category is the electrovalent compound, or you can say that ionic compound. In this compound, transfer of electron takes place. It means one atom is donor, another atom is acceptor. So, an atom can transfer if it has more electron than object, or an atom can accept electron if it has one electron or more than one electron less than object. I am taking here example of sodium and chlorine. When sodium chlorine combines to form sodium chloride, here sodium has 11 electrons, so it has one electron in its outermost orbit, whereas chlorine, it has 7 electrons in its outermost orbit. You can see that in chemical bond what is happening? A rearrangement of electrons in the valence set. Very, very important points. Here, electron of sodium is, one electron of sodium is transferred and is given to Cl. So, rearrangement of atom takes place, that means sodium transfer, it loses its one electron, whereas Cl gains its one electron, and after transferring, sodium develop one positive charge and Cl develop one negative charge. Due to charge formation, it is also called ionic bond or electrovalent bond. So, to show the bonding, we can use either orbital diagram or the dot formula. So, I prefer dot formula because this is easy and you can easily explain the types of bonding in different types of ionic compound. So, the first examples I am using sodium chloride, how the bond formation, dot structure, it can be explained in NaCl. Na has 11 electrons. So, when we are going to form dot structure, when we are going to show dot structure, we need only valence electron. That's why I am saying bonding, or you can say that stability is the rearrangement of electron in the valence state. So, here only one electron present with the sodium and Cl has 7 electrons in the valence state. So, one electron of sodium is transferred to Cl. After that, Na develops one positive charge and Cl develops one negative charge. A bond will develop between Na and Cl. This bond is called ionic bond. This is a very, very strong bond because here positive and negative charge are present between two bonded atoms, and there is an attractive force, or you can say force of attraction develops between the bonded atom. That's why it is also called electrostatic force. The bond that develops between ionic compound or electrovalent compound is an example of electrostatic force, where force of attraction develops between oppositively charged atoms. So I will take some more examples related with electrovalent compound or ionic compound. Another examples of electrovalent compound: bond between magnesium chloride, bond between magnesium oxide, bond between aluminium chloride, bond between sodium oxide. There are many compounds which show electrovalent bond or ionic bond. I will explain this and this, because in NaCl single bond formation takes place between NaCl and NaCl2 two bond formation, two ionic bond formation takes place. So here Mg, Cl and Cl, it has its electronic configuration is, in the rough you can say it is 12, so it is 2H2. Its valence electron is 2. And Cl valence electron is 7, I have already explained. Here also it has 7 valence electron. So 1 electron magnesium gives to 1 Cl and this another electron gives to another Cl. After transferring its 2 electron, magnesium develops 2 positive charge, whereas each Cl has 1 electron extra. 1 electron each Cl has taken to complete its octet. So here 2 Cl are there, so we can write 2 Cl minus 1. This is the type of bond develops between Mg and Cl. Similarly, in case of aluminum chloride, there are single aluminum and 3 chlorine atom. Aluminum valence electron is 3, its atomic number is 13, so its valence electron is 3. Out of 3 valence electron, 1 it gives to first Cl, second Cl and third Cl. Here the same thing, 7 electron. And after transferring, as aluminum has given 3 electrons, it will develop 3 positive charge, and 3 Cls are there, and each Cl have taken, each Cl has taken 1 electron, so 1 negative charge develops. So in this way, ionic bond formation occurs. One example of dot structure, I have given many examples of dot structure. One example of orbital diagram also I want to explain. Suppose for any Cl. When we are going to show orbital diagram, here we write the orbit, we draw the orbit where electrons are present, and we have to show the number of electrons in that orbit. For example, NaCl, Na has 3 orbit it has. In the first orbit 2 electron, in the second orbit 1 electron, 8 electron, in the third orbit 1 electron. Cl 17, first orbit 2 electron, second orbit 8 electron, third orbit 7 electron. So like this we can draw first orbit 2 electron, second orbit 8 electron, and third orbit 1 electron. Cl first orbit 2 electron, second orbit 8 electron, and third orbit 7 electron. So the one valence electron, one outermost electron of sodium has been transferred to Cl. After that, here sodium will have only 2 orbit, first orbit 2 and 8 orbit has 8 electron. Its stability has been fulfilled because it has octet configuration. Cl, here it has first orbit 2 electron, second orbit 8 electron, and in the third orbit also 8 electrons are there. So here Also, the octet of Cl has been completed and it develops one negative charge. So this is the main aim of bonding. Wherever bonding, chemical bonding occurs, then its purpose is only to fulfill either octet or duplet configuration. It means an element wants 8 electron or 2 electron in its outermost orbit. Now I will explain what are the conditions required for the formation of electrovalent compound or ionic compound. So, for the formation of electrovalent compound, the first condition is element must have low ionization potential. I will explain in detail what is ionization potential. It is also called ionization energy. Second, the elements must have high electron affinity. And third, they have large difference of electronegativity. There is a large difference of electronegativity between the bonded atoms. So, the condition for the formation of electrovalent compound I will explain in detail. This is the part of periodic table. This topic we study in the periodic table, ionization potential, electron affinity and electronegativity. This is a part of periodic table, but as it is used for bonding, that's why I want to explain this topic in detail. So the first point is the ionization energy, or you can say that ionization potential. Suppose an element X is taken, and to convert element X to X plus, that means to remove an electron from a given element, the amount of energy required is called ionization potential. You can say it is the amount of energy required to remove outermost electron from an isolated gaseous atom. So, if this ionization potential is less, then it will be easy to remove electron, and ionization potential is large, then it will be difficult to remove electron. That's why the first condition for electrovalent low ionization potential, that means least amount of energy is required to remove electron from an isolated gaseous atom. And if we see the periodic table, then we find that group 1 elements have lowest ionization potential. In group 1 elements, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, as it is radioactive, so we don't use this. So when we go down the group, atomic size increases, electrons are far from the nucleus, electrostatic force decreases, so it becomes easy to remove electron. That's why ionization potential increases in the group. When we go across the period, that is group 2, here it is beryllium, magnesium, aluminium, calcium, strontium, barium. So if we see, when we move from lithium to beryllium, lithium has 2-1, it has 2-2. Both lithium and beryllium belongs to second shell. Period is the second. So size of lithium and beryllium are same, but the valence electron increases. So electrostatic force of electron, electrostatic force between the electron and nucleus increases. So atomic size decreases. So we can say that beryllium is smaller in size than lithium. And as beryllium is smaller in size, so electrons are closer to the nucleus. So it will be difficult to remove electron from beryllium than lithium. So we can say that in the period, ionization potential increases. That means more energy is required to remove electron, and in the group, ionization potential decreases. So the first condition To form an ionic compound or electrovalent compound is low ionization potential, and we have got an information that group 1 elements are the most suitable elements for the formation of ionic or covalent ionic compound or electrovalent compound. Group 2 also can form because their size is not so small that in compare of group 1. So they can also form electrovalent or ionic compound, but group 1 is the most suitable group for the formation of ionic or electrovalent compound. The second condition for the formation of ionic compound or electrovalent compound is high electron affinity. Very important point. Electron affinity is opposite to ionization potential. Here, it is the amount of energy released. It is the amount of energy released when an electron is added to an isolated gaseous atom. Here electrons are being added. Ionization potential electrons are being removed. So to for removal we need energy, and when electrons are being added, here some amount of energy is released. That energy is called electron affinity. So if you see the periodic table, then you find that group 70, it is also called halogen group. Group 1 is alkyl metals. Group 17 is halogen groups. So here the elements are fluoro, chloro, bromo, iodine. These elements, fluorine is the strongest non-metal in the periodic table. Fluorine has the highest tendency to attract the body electron towards itself. So we can say that when we go across the period, electron affinity increases. More and more electrons can be easily added because if we go across the group, across the period, size decreases. So when we add electrons, electrons are being strongly pulled by the nucleus. So a strong bond formation takes place. That's why electron affinity increases in period and electron affinity decreases along the group. So we can say that for electrovalent compound or ionic compound, most suitable group is group 1 and group 70. That's why NaCl is a strong ionic compound. It is a strong ionic bond. Third point, that is large electronegativity difference. Large electronegativity difference. Electronegativity difference is tendency to pull electron. Electronegativity is a tendency to pull electron. So one atom will develop positive charge, another atom will develop negative charge. As group 1 elements have a tendency to transfer electron easily due to its bigger size, and group 17 elements have tendency to gain electron due to small size. There is a large electronegativity difference present between group 1 and group 17, and they will form a very strong electrovalent bond or electrovalent compound. So we can say that there are 3 conditions must be satisfied for the formation of electrovalent compound or ionic compound. First, elements must have low ionization potential. Second, elements must have high electron affinity. And third, a large electronegativity difference present between the bonded atom. Now, I will introduce another types of chemical bond, that is covalent bond. Second example of chemical bond or second types of chemical bond is covalent bond. where sharing of electron takes place between two atoms. So, sharing means both atoms must have deficiency of electron. Both atoms must have electron less than octet. That's why sharing takes place between two atoms. So, it is a type of bond where sharing of electron takes place between two or more than two bonded atoms. Two or more than two bonded atoms. And all the atoms must have equal contribution while sharing of an electron. So, the first category, first example that I am showing, single covalent. Here one thing I want to explain that there are two types of covalent bond. Once a covalent bond formation takes place between two similar atoms. It is also called bond formation between homoatomics. It is homoatomic atoms. Or you can say molecule of an element. And second is the bond formation between two or more than two different atoms. So you can say it is a heteroatomic atom. Here one very important topic I am going to introduce. When the bond is formed between two similar atoms, such type of bonds are called non-polar bond. Very important points. Polarity, dipole moment. This is one of the most important part of chemistry as well as in physics. In physics, electrostatics, we study dipole moment. How to find out dipole moment? What is dipole? Derivation of electric dipole moment. You add derivation of electric field to dipole at its axial position or equatorial position. So, when the bond is shared between two similar atoms, this type of bond is called non-polar bond. And when bond is atom, this type of bond is called polar bond. So, there is another name. So, first I am going to explain bond formation between two similar atoms, that is non-polar bond, and it has three types of bond. First is the single covalent, second is the double covalent bond, and third is the triple covalent formation. In single bond present between two atoms, so you can say that sharing of one pair of electron takes place. In double covalent bond, double bond develops between two atoms, so you can say sharing of 4 electron or 2 pair of electron. In the triple covalent bond, sharing of 3 pair of electron, so triple bond develops. So hydrogen. Here the dot structure that we are going to show for hydrogen, there is a single electron present and hydrogen cannot fulfill octet. It will have duplet configuration. That means if it will develop 2 electrons at its valence shell, then it becomes stable. That is duplet configuration, and due to sharing of 2 electrons between hydrogen atom, a single covalent bond develops between 2 hydrogen atoms. Here each atom uses its 1 electron, so we can say that equal contribution of both the atoms are going on. That's why such type of bonds are called covalent bond. Another example for double bond, we can use oxygen, O2. Now, this is an important point. We should know that how many electrons must be shared between two atoms. For hydrogen, there is single electron, so we can simply say that 1 electron is there, shared between two atoms. But for oxygen, it has 6 electrons in its outermost orbit. Its atomic number is 8, and it has 6 electrons. So, just we have to see the valence electron. Oxygen valence electron is 6, and to fulfill its octet, it needs 2 electrons. That means out of 6, 2 electrons present between 2 oxygen atoms, and the remaining 4 present as a outermost electron. This oxygen also has 6 electrons, so it will also put 2 electrons between 2. One thing remember, the number of electrons, first we have to see valence electron, and the number of electrons required to fulfill octet, that much electron must be placed between 2 atoms. It has 6, so it needs only 2. So out of 6, 2 will be inside, remaining will be outside. So here sharing of 2 pair of electron takes place, and you can say a double bond formation for 4 electron. For single electron, 2 electron we use single bond. For 4 electrons we use double bond. 4 electrons we use double bond. So double bond formation takes place between 2 oxygen atoms. Third is the nitrogen. This is triple bond configuration. Just you have to again look the its valence electron. Its valence electron is 5. So out of 5, 3 will be between 2 atoms because it needs 3 electrons to fulfill its octet. So 3 electrons present inside and the remaining 2 outside. 3 electrons present inside, the remaining 2 outside. So here 8, here 8. So we can say that nitrogen has triple bond formation, triple bond. Using this bond we can also explain which one is more stable, which one is more reactive. Higher the number of bonds, higher the number of electrons, higher the electrons are shared, stronger the bond formation. Lower the electrons are shared, weaker the bond formation. So in this way, single bond, double bond or triple bond formation occur between covalent compound. Now I will explain bond formation in a heteroatomic atom, or you can say that polar bond formation. So first example I want to take HCl. As I have explained, NaCl, and I will make difference between HCl and NaCl. H has single electron in its outermost orbit and Cl has 7 electrons. So out of 7 it needs only 1 electron to fulfill its octet. So out of 7 it will put only 1 electron between 2 and the remaining 6 present as a valence electron, as a outermost electron, not valence electron, outermost electron. And this bond develops between octet of Cl has been completed and duplet of hydrogen has been completed. So we can say that a single covalent formation takes place between H and Cl. So there is a question why it is called polar bond? Because chlorine is a highly electronegative element. The electronegativity difference between hydrogen and Cl is very large. So the bond that develops, this bond shifted little bit towards Cl, and due to shifting of this bond, Cl will develop partial negative charge, whereas H will develop partial positive charge. So wherever such type of situations are there, that means one atom has partial positive and another atom has partial negative, this type of bond is called polar bond, and in case of polar bond, we calculate dipole moment. But the one thing that is important to note, that as much positive charge develop on one atom, that much negative charge must be present on another atom. That means electrons appears in a equal and opposite forms. Or you can say charges appear, not electron. We can say that positive or negative charges appears equal and opposite sign. So this is an example of polar bond, or you can say that heteroatomic. Second is the CO2, carbon dioxide. Carbon dioxide here It is a symmetrical compound. Carbon has 6 valence electron. Sorry, it has 4 valence electron. Oxygen has 6 valence electron. This also has 6. So 4 here. This oxygen has 8. This oxygen has 6 electrons. 2 will be here, remaining outside. This also has 6. So 2 will be here, remaining outside. So octet of oxygen has been completed. Octet of oxygen has been completed. And octet of carbon has also been completed. So we can say that a double covalent bond develops between oxygen and carbon. This compound, this bond is called polar bond, but it has zero dipole moment. Because the polarity of this bond is this side and the polarity of this bond is this side, both will cancel. So its dipole moment is zero. Another example is ammonia, NH3. Here nitrogen and 3 hydrogens. So wherever hydrogen present in a given compound, there is no confusion. Sharing of single electrons between the bonded atoms. Nitrogen has 5 electrons. So as hydrogen has given its 1, here also nitrogen will give its 1 electron. And the remaining 2 electrons present outside. So duplet of hydrogen and octet of nitrogen. So here we see 2 different types of bond. All are covalent, but here 2 different types of bond. This is the called bond pair, and this one is called lone pair. Very important point. Electrons which are not involved in bonding, they are called lone pair, and electrons which are involved in the bonding, they are called bond pair. So in ammonia, nitrogen has 1 lone pair. This lone pair will play a very important role when we will discuss other chapters. Basically, shapes or hybridization of the chemical bond. Now, for water, again we do the same structure. Water has like this. Water molecule, we can say that there are 2 lone pairs. 4 electrons are present, that is 2 lone pairs are present in the water molecules. So we will discuss the third type of covalent bond is coordinate bond. Third type of bond, coordinate. So coordinate bond is a type of bond which develops between 2 atoms in a given compound, but the bonded atom is contributed by a single atom. So one example I am using of coordinate compound is ammonium ion, another is hydronium ion. This is an example of coordinate compound. So for coordinate bond, first I will explain. This is ammonium ion. Ammonium ion is combination of ammonia plus H plus ion. That is ammonia. So if we draw the structure of ammonia, then we find that ammonia has 3 hydrogen, 3 bond between nitrogen and hydrogen and 1 lone pair. This combined H plus. H plus is a proton because it has no electron. So this electron that is lone pair, this lone pair is going to be shared between nitrogen and hydrogen. So we can write like this. For coordinate bond, we use arrow. And this arrow, the head of the arrow tells that from where which is contributing electron and which element has taken the electron. So like this. And we can draw the double bond. So this is an example of coordinate bond. Here the electron is shared between nitrogen and hydrogen, but this electron belongs to nitrogen. The 2 electron belongs to nitrogen. But coordinate it has given its electron to hydrogen also. So both are sharing but contributed by single atom. That's why it is a coordinate bond. A type of bond where sharing of electron takes place between two bonded atoms, but electrons pair belongs to a single atom. Hydronium ion is combination of water plus H plus. So as we know that water has two bond and two lone pair, two bond pair and two lone pair. So it combines with H plus. So a coordinate bond develops between, and we can show the arrow. This is an example of coordinate. So all these examples are types of covalent bond. First is the types of bond. First is the electrovalent bond. Second is the covalent bond. And third is the coordinate bond. And now I will give some question based on this concept. So these are the questions that are based on the concept that I have given. First, how do atoms attain noble gas configuration? I have already explained. Noble gas configuration means to have stability. It can be possible either by transfer of electron or by sharing of electron. In transfer of electron, we get electrolytic compound, and sharing takes place in a covalent compound. So you will explain this electrolytic and covalent compound here to explain the answer of this question. Second condition, what are the conditions for the formation of electrovalent bond or ionic bond? So first condition I have already explained. The metals must have low ionization energy and potential, or you can say elements must have low ionization energy and potential. Second, elements must have high electronegativity. And third, large electronegativity difference present between the bonded atoms. What is difference between non-polar and polar covalent bond? When a bond develops between two similar atoms, or one example here I want to say CH4. Here bond develops between two different atoms, but it is a non-polar bond. Because the electronegativity difference between carbon and hydrogen more or less same. So we can say that methane is a non-polar bond. So non-polar bond is that type of bond which develops between two atoms or between two or more than two atoms having negligible small electronegativity difference. Whereas polar covalent compound is a type of bond where sharing of electron takes place between two atoms, where large electronegativity difference present between the bonded atoms. Example HCl, example ammonia, example water. Then what type of compound forms between metals and non-metals? Metals are electron with excess electron, element with excess electron, and non-metals are element with deficiency. So the type of bond develops between metal and non-metal is electrovalent. Next, an atom X has 287 electrons shell. It's combined with Y having one electron in the outermost. What type of bond will be formed between X and Y? X has here Y and X. It has one electron in the valence. It has 7 electrons in the valence. So this electron is going to be transferred from Y to X. So what type of bond? What type of bond will be formed? It will be electrovalent compound. Mind it, here it is written that combines with Y having one electron in the outermost cell. Innermost cell, how many electrons are there? It is not important. Sodium 287, so 10 is not important. Magnesium 282, so 10 is not important. So we have to focus on the valence electron. And second X has 287, it is a 17 chlorine. So transfer of electron takes place, so that type of bond will be electrovalent compound. And formula, whenever we are going to make formula, we write electropositive element first and electronegative element later. Or you can say that metals first and metals later. So it will be YX. This is the compound of the formula of the data. So in the next video, I will explain some more information about chemical bonding. Thank you.